find out. It's not dropping frames. So. Okay, go ahead and get set up. Today is going to be the review, but we'll obviously, since we had a hurricane and we lost some class time, we still have to do some regular lecture. Make sure it's actually recording. I guess we'll find out later. Okay. Normally you can refer to the lectures from summer, but obviously those don't have like a midterm review, if you noticed. But anyway, so today I'm going to record the lecture. We've got our midterm in 1 week. Very quickly, it's going to be 2 programming questions, so it's not just so you're prepared. It's not multiple choice, short answer, or anything like that. You're actually going to have to write code, which sounds bad, but it's not. If you've been doing okay on the homework assignments and you kind of understand what's going on, most people do okay. Lots of A's and B's. I mean, I can't speak for everybody, but in general, if you understand and can do the homeworks on your own, then you should be okay for the exams. But again, there's always going to be outliers. I don't want to say everybody, so still study. It's still important. These students, you'll know who you are, but if you have special permission from your counselor, email me. I just want to get a sense of how many people and what accommodations and so forth, okay? You can use any code examples that we've done from class, or you can use your assignments, but you can't use external websites. Obviously, you can still use Blackboard and REPL, but you can't use notes, chat program, pretty much everything else. Okay, everyone's very clear on this. So if I catch anybody else, like, it seems like every semester I catch probably one person and one to 2 people in one of my classes cheating, and I still don't get it. After this many years I've been at IRSC, I make such a big deal not to cheat, and I always catch a couple people cheating. And there's no argument. I was just checking something real quick. It's just a 0. The reason I'm so strict on cheating is because it's just not fair, because there are some people in here who really struggle and do the work on their own, and they earn their B or C. It's not really fair for you to cheat and get an A. And it's not going to help you in the long term anyway, because if you're cheating in your, your freshman level courses, I don't know if this counts as freshman, but the courses in your first couple of years, if you're already cheating, you're not going to make it to senior year, because everything builds on each other. Okay, you have to do this on an IRSC computer, so that I can monitor all your computers from here, and I mean, the reason should be obvious. So, and then I'm recording today's lecture, so I'll give you some hints, but these are the basic rules. Okay, so I'm not going to give you anything else like rule-wise, not written, but I will give you some hints how to organize your work and stuff for the exam. Okay, so any question on these rules? Is everyone very, very clear? Yeah. Yes, same time and everything, yeah.
Okay. And are we going to be coding in REPL?
Yes. Now, I wouldn't 110% rely on REPL being to where, like, I think how to say this. I would download your code examples just in case, because who knows, a million things can happen. You can accidentally lock yourself out of your account, you know what I mean? So, but we'll talk about that in a second. Any other questions? Okay, so let's go ahead and get started. The best way to study, so I already told you it's going to be 2 questions. It's going to be based on assignments 3 and 4. And I realize I haven't graded 4 yet, but I'm going to give you the answer for 4 today. So sometimes I'll do like a question based off of this, but this is so simplistic that it makes life a little bit easier, that let's just, rather than a three question exam, we'll make it 2 questions. Question 2, or assignment 3, kind of already has everything that assignment number 2 has in it anyway, since it builds off each other. So rather than having you do 3 questions under a stressful environment, I'll just have you do 2 questions. The best way to study, obviously, is assignments 3 and 4. I'm going to give you the answers, but as I give you the answers, I'm going to give you a bunch of little hints along the way for organizing, okay? So let's go ahead and let's go ahead and just get right on that. So resources. I'm trying not to take up too much class time with announcements, but it looks like I already burned through 10 minutes. So let's first start with assignment number 3. And what I would suggest on your exam is taking the exam questions and putting them in your exam somewhere as a comment. So maybe at the very top. Now, one quick thing, I don't know if we went over this. There are these things called multi-line comments. You know how normally we have a comment where we do 2 slashes? There's another type of comment called a multi-line comment where you can do the slash, star, star, slash, and now everything in between that is considered a comment. Does that make sense? That way you don't have to do a slash for every single line. This helps because obviously you don't have to flip back and forth between your code. So obviously this should be one of the first things that you do. Even if you completed the assignment and got 100 on it, I would still highly suggest going through the whole process of actually typing this. Oops. Just to get some extra practice, because you know some of these assignments we did 6 weeks ago. Nope. Is that still okay? Everyone can see? Okay. I'm seeing all kinds of lines because I looked into the projector for a second, which was a bad idea. Okay, so just as a quick thing, right now, obviously I'm grabbing these formulas from an external website. On your exam, any sort of formulas or whatever, I'll provide you with those, okay? So you're not going to have to look up stuff externally. Like if we're doing miles to kilometers, I'll actually provide you with that formula, okay? In this case, this is the homework assignment. This is a little bit different. So one of the first things that I would do is when you're solving these, just gather all the information you have, okay? So this one was, we had to go Celsius to Fahrenheit, and then Fahrenheit to Celsius. So let's collect those formulas and let's kind of just get those together, get that part out of the way. And so we talked about this before. It can't be on the right-hand side. Don't forget, don't use capital letters for variables. Remember, I talked about that. Okay. We'll talk about that more as we get into the course, but basically it usually implies that it's a constant or a class or something else. It implies something, so let's keep our variables lowercase. And so here, since they actually solved it, we don't want to say 10c equals, you know, we want to say just c equals, well, they're providing an example value. We're going to have the value. And we can't just write f minus 32. What do we have to write instead? Or what do we have to do instead? We have to actually put it in parentheses. Remember, the order of operations works the exact same. And then we don't use the x for multiplication. What do we use instead? I hear people whispering it. Say it confident. Star. Perfect. And then it's dot. So don't use the fraction version because I don't want to get into integer division. It causes some problems. Whatever. I don't want to get into it. So okay. So we've got that. So this one is which direction? This one, the user is providing Fahrenheit, and then we return Celsius. So this is Fahrenheit to Celsius. So maybe I'll even put a little note here, Fahrenheit to Celsius. And then I'll go through this one a little bit faster. So C times 1.8 plus 32. Is that right? C times 1.8 plus 32. Okay. Maybe it's because it's not spaced out. That looks funny to me. Okay. And then this one, they're providing Celsius to Fahrenheit. I got the parentheses right. Okay. So you got that part. If we know it's going to be a menu-based system, and they're going to have to press 1 for something and 2 for something else, okay, start to think about the problems in this fashion. Think, okay, I've got an assignment that's sort of similar to this. So one of the things you may want to actually do is bring up a similar assignment. So obviously my assignments are very scattered, but let's say we did something like this, I don't know, maybe 917, something like that. Now there should be a program installed on everybody's computer called Notepad++. I would highly suggest opening your code examples inside of Notepad++. Okay, so first of all, this has a bunch of extra examples I don't want, so I could just right click and close everything, but let's try that again. Let's say, for example, I think, oh, I might have done something like this a couple of weeks ago, and okay, so we see a similar example. And so what you can do is, if you kind of align these right, my fonts are obviously huge because I'm lecturing right now, but you can shrink your fonts, and then what you can do is put these side by side, and obviously in this case, since the fonts are a little bit smaller here, maybe we don't need so much room. Something like this. That way you can have as a template to work off of. And you say, okay, well, this is going to be a menu-based program. Oh, okay, so this example kind of looks like a menu-based program. So at the very least, I know they're going to have some choice. I know Fahrenheit and Celsius are going to be involved somehow, so and then just kind of using your pattern matching ability, say, okay, well, the next step, this was a conversion program, and this program, I printed out a menu, so let me do that, but the menu is obviously going to be different. So here I'm going to say, press 1 for Fahrenheit to Celsius. Celsius to Fahrenheit. Be able to recognize which exact parts of the program require either no change or almost no change. So this menu, literally the only thing that changed was just, the labels here, but we're even using the same variable name, choice. And again, using your pattern matching abilities, say, okay, well, since it's a menu-based program, I would highly suggest having something like this, set up, because for most people in the class, if you're new, and I imagine probably over 90% of the class, this is like your first head, if choice is equal to 1 and choice equals to 2, else. So let me go ahead and set that up. So if choice is equal to 1, else if choice is equal to 2. Else, and we know since this one only has 2 choices, cout invalid choice. Now, one of the most common mistakes that I see students make on these exams is writing way too much code without testing. Even here, I might be a little bit, I should have actually probably tested a little bit earlier. But to me, this is kind of getting on the edge of how much code we can write before doing some testing. Okay, so first of all, it compiled. Okay, well, these 1 and 2 aren't going to work, but what is going to work? Invalid choice. So let's go ahead and put an invalid choice to make sure at least that much works. Okay, so at least something works. I would say for most people, now would be a very good time in your exam to do a Control A, which highlights all, Control C, and then go over here, open up a new tab, and paste it in. That way, if you like mess up on your exam, again, you're under very tight time constraints. If you need to go back to a previous version, you've got it right there. I mean, some of this stuff may seem obvious, but I've just seen student after student make this mistake where they got 2/3 of the way through. Because if you turn this in, I would still give you some credit. Obviously not, full credit, but you'd get something. Versus if you turn in something that doesn't even compile and it doesn't even look like any logic, anything near to what the final answer should be, then, especially if it doesn't compile. That's the big thing, is that if it compiles, that to me, that sort of shows me that at least you kind of see what's going on. You know what I mean? If you submit a bunch of code that doesn't even compile, a lot of times I'm just like, does this person even, I sort of have to start questioning. I was like, okay, well, did they make backups? At what point did it not compile, and so on? So always make backups. But now let's get back to this. Okay, so these are just little tips along the way. And if I'm going Fahrenheit to Celsius, I'm going to ask the user for Fahrenheit. So on this other version, we asked them for liters and then store liters. But now say, okay, well, here I'm going to enter Fahrenheit. And then we're going to return Celsius. We want to find Celsius, so we say Celsius equals. But remember, because we did that work up front, we already have that. So all we have to do is just copy and paste, because we already set up the formula at the beginning, knowing we're going to need that. And then we could do a very simple cout that says now, normally in a real-world program, you'd actually want to write the full words like Celsius. But again, this is an exam. You're under time constraints. I don't really care if you know how to spell Celsius or Fahrenheit. I just want to know if you know how to write code. And on the opposite side of that, again, we can follow this. So here we are going Celsius to Fahrenheit. So we ask the user for Celsius. We store that, and because we prepared, we have that formula. And then now we can't just be done with it and say, okay, well, the formula looks good. Test it, and test it with obvious values. So if I say 1 for Fahrenheit to Celsius, what's the most obvious 2 values? Bless you. Freezing and boiling, right? So what's freezing in Fahrenheit? 32. So what should that return in Celsius? Okay, so that looks good. And then 212 is boiling. That gives us back 100. It's not going to be exact because of, what we're doing, but, and then the same thing here. Oops. At least that worked correct. I just entered it in wrong. So 0 degrees Celsius, that should be 32. Perfect. And at this point, maybe, don't necessarily trust a web browser to freeze on you, because I've seen that happen to people. Again, Control A, Control C, just have a backup just in case. Just open up another tab, paste it in, just to make sure that you've got, okay. I've seen a lot of students on homework assignments especially, but on exams as well, have like 80% of the logic correct, and it's like something's like a little bit off. And if they had tested it, it would have been pretty obvious what was off. But like I put in numbers, and just nonsense answers are returned. So always, always, always test. Think in your head, what's the most obvious answer? If I'm going miles to kilometers, probably 1 mile is the most obvious. And then whatever that conversion formula is, it should be 1 times some number. So things like that, okay? I'm going to pick up the pace a little bit for the second example because it's the same. It's kind of the same idea. So what we're going to do is we're going to open up another REPL. Close this, and so first thing is that we get the actual text from the problem, put it somewhere at the top of the file. To me, probably makes most sense. Do it as a multi-line comment, paste it in. Now, in my opinion, this is maybe a little bit long, so we can get rid of the stuff, read the problem, but okay, create a program which calculates shipping costs. That paragraph's just kind of taking up room. This is probably taking up some room. And then maybe we want to just kind of condense this and say slow is 1.0. And then we can get rid of this other stuff. Okay, so now we've really condensed this, so we have more room to write our program. Now, one of the first things I would do is, well, obviously, besides your hello world, make sure at least that much works. Is find the example that you think is closest to the problem. So in this case, this is our shipping example. We'd probably have to go back to something like our gravel problem. So I'm going to close all. And you obviously would save, but in this case, I'm not going to. So you might say, okay, we might have done the gravel problem on this date. See if we have something here similar. And okay, so we found that problem. And then you can kind of drag things over to make everything fit. Probably don't need so much area over here. And to me, I see this, and I see this as a 2-part problem. First, I'm going to solve the gravel problem. So before I even worry about the second half of this, I want to kind of isolate this and treat this as its own independent problem, just this first half of the problem. And I look at this and I'm like, well, what's the difference between like the weight of a box from UPS versus the gravel weight? nothing really, so I can probably even just use the same exact variable names, okay? We should initialize our variables to 0. We'll talk about this in more detail after the, maybe even today a little bit, but more so after the midterm. And we know there's 3 rates here. So I look at this and I know right away, okay, it's going to be an if, the first thing, else if the second thing, else if the third thing, and then finally an else. And we did the return 0 thing. Remember what that does? That just kind of stops. So main is a function. It actually returns the function early, so it's the equivalent of stopping the program early. We'll talk about that more when we get into functions. Now in this case, this isn't really helping me at all at the top of the file, so maybe I want to go ahead and move this down closer to my logic to where I can actually see it. Part of this problem was that this rate table isn't completely like you can't really implement it as written, so you kind of have to take some liberties. And this is not that uncommon to get something like this from a customer. So we'll follow this general pattern. Okay, so it was if the weight is greater than 0, and don't forget we can't just say and less than some value. We have to say and pounds less than. Well, in that other case, in this one, this one's very simple because literally all we're doing is switching around some numbers. So the other one was 0 to 10 pounds. This is 0 to 1 pound. So that seems pretty straightforward to me. And then we just keep on filling it in. Not points. Then it's going to be less than 3. And then you could take some liberties with the last 10 pounds exactly. You could do up to 10 pounds. Again, the chances of somebody weighing in at exactly 10 pounds are so small that it doesn't matter. And so here we're going to say that the price is equal to the weight, so the number of pounds, times, in this case 5. And again, it's just kind of symmetric. A lot of pattern matching. It's going to be 5, 3, 2. Now I look at this and I say, this is a perfect opportunity to test. This is like enough code to actually test something usable. So I can run it, but I need to add, the goal is to see if it's calculating price correctly. So let me just temporarily add in a cout statement just to see if it's calculating the price correctly. And let me just pick an arbitrary test point. If I pick 2, that should be between here. So it should be 2 times 3, which is 6. So let me run this. Okay. And this is good. So we've set up the rate table, but what did we forget to do? We forgot to actually ask for the weight. So let's go ahead and add that now. Pounds is actually probably a bad variable name. I shouldn't have done that. Probably weight's better because then you could change units, but I guess it doesn't really matter that much for this program. So now we should be able to actually test this thing. Okay, so we know at least that much works, and then again, paste that in so we've got a copy. Now it turns out that's as much as we can use with this example, because the second half we had to do on our own. So be able to recognize that maybe there might be part of the program where there is no exact counterpart. So now we have to go back here and say, okay, the idea was to take this price calculated from before and then multiply it by a value. Well, I want to know what speed they want. So what I have to do now is I have to print another menu. So let's do that. Go ahead and ask them for their choice. Now this program doesn't have a choice variable yet. So here's where we would introduce a choice variable. Typically you want to put all your variables at the top. You can put them anywhere, it'll still compile, but it's just kind of like a, I don't know what the word is. It's just kind of like a common thing that programmers do. Like a design choice. But let's put it in the middle just so we know it's possible. So let's say int choice. Let's not put it here, let's at least put it above the menu. And we can initialize it to 0, just so it's zeroed out. And then we would say cn choice. And then again, it's very pattern based. It's going to be like one of these: if choice is 1, else if choice is 2, else if choice is 3, else the choice is invalid. A lot of this is pretty boilerplate. A lot of this doesn't really require a whole lot of thought. So now the last part is that we have to say, okay, how do I actually find the price, the final price? So I have this kind of temporary price where I found the base price, but now I want to find the final price, and I know from this rate table, it's going to be that price that I found, and this is what I saw, and I've seen this for, you know, anytime I've used this assignment. What people will do is they'll, you know, not really think it through, and they'll just grab a random variable and multiply it. Really think it through of what we're actually calculating. We're taking the price and we're increasing it by 10% or whatever, 50%. It doesn't really make sense to multiply the weight by 1.5 because then it's like, what does that get you? That just gets you a larger weight. What we want to find out is the price. So really think this through. Don't just start grabbing random variables, because I've seen a lot of people do that in their code where you're just kind of mindlessly typing and not really thinking through and just trying random stuff until something works. Your programs aren't going to work very well if you do that. I would actually generally suggest most people keep like a little scratch paper just to kind of make notes and think things through. We go through this kind of fast in class because these programs are, you know, they're not overly sophisticated. Most of them are under 100 lines of code. But if you really can't think of, like, you're here and you're like, what do I do next? Just kind of write some things down. Write what you know. Write the things that you could multiply. Say, okay, would that make sense? So in this case, we want to multiply the price times some value. Now that gets us a result, but where do we store that? Well, don't forget the way these are evaluated is that it's evaluated on the right-hand side of the equal sign first. So it's going to be price times 1, and then it's going to store it back in price. And then once you've gotten this once, you can usually follow the pattern. Now again, avoid string comparisons because it can get kind of confusing. Like if somebody has a capital S for slow, use wherever there's a menu choice like this, just default to integer numeric based menus like we did here, okay? These are a lot simpler. We don't have to worry about, you know, if they mistyped, not even mistyped, but, you know, case sensitivity issues. Anything like that, okay? And let's go ahead and test it. So if I enter in 2, we know it should give us 6. Perfect. And then now if I choose, let's say this, 1/2 of 6 is 3. So that should give us 9. Oops, okay. And then one last thing, what do we have to do? We have to actually output the result. But let's try that one more time. Which one did I want to go with? 2 times 3. Okay, yeah. 2, fast, perfect. Okay. and then save this. Like this would be a good time to save. Then if you have some time at the end of your test, go through and test as many scenarios as you can. Go through on paper and scratch and say, does that look like a reasonable result? Like if here I had entered in, okay, I mean, I'm no math genius, but 6 times 1 is going to give me 6. So if I enter in 1, that should just return 6. Okay, so go through little scenarios like that. Okay, so we have other stuff to get to today, but you get the idea. Keep your notes organized. Make sure that you are comfortable like pulling the window off to the side and having your notes over. Keep your notes organized. Follow all the rules. I'm very, very, very strict about tests because I just don't think I've just seen too many students really work hard to earn their B or earn their C and get through the course and just be really proud of themselves. And then it's just not fair for somebody to just kind of cheat and Google stuff, have a chat program open, and then like give their friend the test questions and then have them solve it, you know, things like that. It's just really not fair for the students earning their B's and C's and, you know, they got that grade on their own. Even to the A students, obviously, as well. Okay, no questions? And everyone understands the actual answers to the assignments? I mean, you've already done them at this point. Okay, so let's leave that aside. Let's actually go into some new material. So that's next week. That's all we're going to do all class. So the reason I have to do that is because I try to keep all my classes in sync. And there's another version of this course that's it's only an hour and 15 minutes long. So that's what ends up happening. I don't want to really cover too much. I don't want to cover new stuff next week when they can't. So anyway, once you're done with the exam, you'll be able to leave, and I'll have those graded in probably in the next week or so after the exam. So let's move on here. We've got a new assignment that probably doesn't make a lot of sense just yet. It is due the week after the exam, but I think most people in here should be able to finish this today. That way you don't even have to worry about it, you know. Finish it today, then you can spend the next week just worrying about your exam rather than worrying about the exam and the assignment. So let's start up a new REPL. So we talked about for loops. So do this. Take a few seconds. I'll kind of give you the setup. What I want you to do is just make a basic for loop that counts from 0 to 5, not including 5. So 0, 1, 2, 3, 4. So I'll give you the basic setup. Okay, so convert that for loop to be able to count 0, 1, 2, 3, 4. So remember the basic parts of our for loop is that we have the setup phase. It's very similar to a while loop. So we'd have our setup phase. Here we'd say int I is equal to 0. That only occurs once. We say, well, I is less than some value, in this case 5. And then we say I is equal to the old value of I plus 1. And then now we can just call it a cout statement. And remember how this works, that, okay, so this occurs once during the initialization phase. This checks each time through the loop. It says, okay, is I still less than 5? And then finally, we had our last part. We had to make progress towards some goal. Eventually, we want I to be 5 or greater. And so what we do here is that we, that's this post part right here. Okay, and actually, this is all recorded anyway. So I recorded the, all I wanted to really record was the review. So